If you thought the images from the James Webb Space Telescope were stunning, get ready to have your perspective completely transformed. A new space observatory has started sending back visuals so detailed and expansive that even seasoned astronomers are admitting they weren't prepared for what they're seeing. Meet the Euclid Space Telescope. Its first light images aren't just breathtaking, they reveal structures in the cosmos we barely understand, patterns shaped by invisible forces, and a universe far more intricate than we ever imagined. Tonight, I'll guide you through what Euclid has uncovered, why scientists are calling these images groundbreaking, and why some of the discoveries are genuinely unsettling. Euclid is no ordinary telescope. Launched by the European Space Agency in July 2023 and stationed 1.5 million kilometers away at Lagrange 2, its mission goes far beyond focusing on a single nebula or galaxy. With its ultra-wide field of view, Euclid can capture enormous sections of the sky in a single observation while maintaining remarkable clarity. This allows it to see individual galaxies while also revealing how millions of them connect into vast cosmic structures. But Euclid doesn't just map light. It detects the influence of dark matter by observing subtle distortions in galaxy shapes caused by gravitational lensing. Essentially, it's revealing the skeleton of the universe, a framework shaped by something invisible and largely unknown. The first mosaic of the southern sky left astronomers stunned. In a brief observing window, Euclid captured 260 images covering an area 500 times larger than the full moon. When combined, these images revealed millions of stars and galaxies, and this represents only about 1% of what the telescope will eventually map. Even this fragment hints at a universe more complex than we've ever imagined. Take the Perseus cluster, for example, about 240 million light-years away. In a single image, Euclid captured over 1,000 known galaxies, more than 100,000 distant background galaxies, and, most surprisingly, over 630 previously unknown dwarf galaxies that had been invisible until now. Because these small galaxies are highly sensitive to dark matter's influence, their discovery suggests that dark matter's structure may be far more intricate than previously thought. Euclid's images aren't just reshaping our understanding of cosmic structures. They reveal chaos and evolution on smaller scales, too. From low metallicity stars in distant galaxies resembling conditions from the early universe to faint stars in globular clusters within the Milky Way, Euclid is opening windows into the history of galaxies and the processes that shaped them. In regions like the Horsehead Nebula, it even detected free-floating Jupiter-sized objects, hinting that rogue planets may be far more common than previously believed. As more of Euclid's data comes in, an unmistakable pattern emerges. Galaxies aren't scattered randomly. They form filaments, enormous cosmic threads connecting clusters across hundreds of millions of light-years. It's a cosmic web, guided almost entirely by dark matter, with everything we see trapped within it. One of Euclid's most remarkable capabilities is measuring gravitational lensing with unprecedented precision. Tiny distortions in distant galaxies reveal where dark matter resides. Massive regions of invisible matter warp the space around them, controlling the movement of visible galaxies. This shows us a universe where most of what shapes reality is unseen, yet overwhelmingly powerful. Euclid also peers back in time. Some of the galaxies in its first images are over 10 billion light-years away, allowing scientists to observe how cosmic structures evolved over almost the entire history of the universe. Early analysis suggests that large-scale structures formed faster than expected, with dark matter organizing itself efficiently and galaxies clustering quickly. This challenges long-held models of cosmic evolution and may require a re-evaluation of how gravity works on the largest scales. And remember, these insights come from only 1% of Euclid's planned survey. Over the next 5+ years, the telescope will continue scanning the skies, filling in gaps, refining structures, and uncovering patterns we cannot yet imagine. What we've seen so far is just a glimpse of a universe that may challenge everything we think we know. Euclid is not just mapping galaxies, it is mapping the unseen forces that govern them. It shows us that dark matter is the true architect of the cosmos, dark energy is actively shaping space itself, and the rules of physics as we understand them may be incomplete. These images are beautiful, yes, but their elegance is the signature of relentless, invisible forces at work across unimaginable distances. The telescope's dual perspective, capturing vast cosmic filaments while resolving tiny details in individual galaxies, reveals a systemic universe. Local processes are shaped by events happening across hundreds of millions of light years. The universe is interconnected on scales we are only beginning to comprehend. Even familiar regions, from the Perseus cluster to the Horsehead Nebula, contain surprises. Dwarf galaxies, hidden star clusters, and faint stellar populations had been missed in previous observations. If we were so wrong about these well-studied regions, imagine how much remains hidden elsewhere. In essence, Euclid acts as a time machine, showing nearby galaxies as they are today and distant galaxies as they were billions of years ago. It reveals the evolution of cosmic structure with clarity never before possible. The universe may have grown faster, more efficiently, and more aggressively than our models predicted.